All right, so thanks to DeepSec for having me. This is my first time a speaker ever, so in case anything goes wrong, it's like, okay, let's see how it goes. So to reiterate, who am I? I do security research at Scientific, which is a small security team doing whatever sounds fun. You can follow me on Twitter. I don't really write much, but whatever. I also play CTF as part of the Flux Fingers team, and I'm currently finishing my master's at Ruhr University Bochum in Germany. So you might have heard in like Crypto 101 that the first thing you should do when you learn about cryptography is to not roll your own crypto, because there's so many things you can do wrong. And we thought about it and we're like, okay, maybe we should just ignore the rule because it might be fun and we might learn something. And today I'm going to talk a little about our design process, our thoughts, and the pitfalls, why it's definitely a bad idea to roll our own crypto. Throughout this talk, I'm going to talk about we and us. And whenever I say we or us, I'm talking about a gaming community. It's a forum board hosted using some popular forum software. And we are always expanding, and we're always looking into like hosting events for the community, and just do all kinds of stuff to continuously expand the community. So in early 2016, the administration came to me and said, "Hey, we're interested in having some kind of tournament for a popular game." And those tournaments, they were hosted a couple times before. They used to be organized by like using Google Forms and spreadsheet for sign up. And that was terrible in terms of organization because it came with like lots of overhead, and the administration and the community wanted a better solution to better manage those signups. So the integration into the forum software itself was not desired due to security concerns. I mean, the forum software was running on PHP, and there were lots of security vulnerabilities in there. So the solution was to put the website on a separate subdomain. So that's what this tournament website looks like. You can like see all the teams, see the tournament tree, and get all the information. And the problem we had was that we need some sort of centralized login, because as you can see, there's like usernames, but we need some way to not have the users to re-register, but instead give them the opportunity to like use the forum login. And our solution for that was the website runs on a subdomain, so we can let it know our forum user ID by setting some sort of cookie. So that was our first iteration. We just stored the user ID, we stored the HMAC of that user ID, so we could verify that everything was in order using some sort of pre-shared key. And then on the tournament website, we could use that user ID to scrape additional data from the user profile. And that worked, but that came with lots of additional overhead. So we had to like account for possible downtimes, we had to do HTML parsing, we had to do everything you have to do when you don't have a proper API. So that wasn't really a lot of fun and didn't really work. Yeah. So in late 2016, the administration came to me again and said, "Hey, we'd like to host some sort of Secret Santa event." So you get some random user assigned, and the random user and you get assigned to some random user, and then you have to organize some gifts for them, and you also receive a gift. And it was right in time for Christmas, and users were supposed to be able to register for the event and submit any gifts. But not everyone should be able to sign up, because you know there were like gifts being exchanged, so you wanted to only give access to the more trusted users, and that's some random user that just signed up to grab some gift and not give anything back. And so we needed some additional forum internal data, like are they qualified to participate, have they ever been infracted for any wrongdoings or anything. And the problem here again was the login. And our solution was again to run the website on a separate subdomain. And this time we not only let it know our forum user ID, but also some additional user data and additional internal data by setting a cookie. So this time we stored user ID, user data, additional internal data in the cookie, and we also created an HMAC of a JSON dictionary containing all that data, so that we could verify that no one has tampered with any data, like trying to set the flag of are they permitted to participate to true, even though they aren't. They required much less overhead compared to our first tournament solution, and it kind of worked for now. But yeah, so essentially we eventually sat together and were like, where are we? What do we want to achieve? And eventually we'd like to provide some kind of API for third-party apps. And we also need some kind of authorization mechanism for internal apps, such as project management, for additional plugins and so on. And the thing is, we don't want to have to write and deploy new code every time we want to organize an event, because as you can see with like first iteration, second iteration, you always have to change something slightly so it always fits your current event. Like sometimes you have internal data such as what was registered before this certain date, and if you have a new event, you have to reset that field essentially, because now you have a new date for the registration cutoff. And so it was way too much overhead. So we thought, and one obvious solution is single sign-on. You might have heard of it, like when you sign into YouTube, you can use your Google account. When you use some app, you can use your Facebook account. And some central identity provider essentially issues access tokens, and multiple service providers can use those access tokens to verify identity and interact with the APIs. There's various implementations like OAuth, OpenID, SAML, and the thing is about it, you might have seen it before, and so we thought about using it, and the obvious question is, why wouldn't you use single sign-on then? Because it like fits everything you want to accomplish. And we will eventually. We're currently working on reworking lots of stuff. We're working on OAuth 2.0 support for third-party apps. But until then, we can just leverage the existing solution we already have in place, utilizing our subdomains. And besides, the presentation would be over by now if we did. So luckily we didn't. Instead, we came up with something ourselves, what you call forever alone sign-on. It's essentially like single sign-on, but it's a bit more stupid and with symmetric cryptography. And essentially, the identity provider issues tokens and stores it as a cookie. And the service provider, so like tournament websites, for instance, they again run on subdomains and therefore can access those tokens. And the service provider can then request the user data from the identity provider using a predefined API. So to show what it looks like in a simple drawing, you got the identity provider, you got the client, and you got a service provider. The client is, in most cases, just your browser, right? So the token is stored in your browser as cookie, and whenever you visit like the tournament website, the cookie is being the token is being submitted as cookie. And the service provider can then use the token to submit it to the identity provider to get all the API data. Like, is the user authorized to access that kind of application, for instance? Or what permissions do they have? And the identity provider can verify that by just storing the cookie, just storing the token in some kind of internal database, and then return an error message or return the response. So we thought about what kind of threat model do we even have? And the most likely scenario is that just nothing's gonna happen because no one cares. We're just not that interesting. We're like a gaming community, and we do what we do for fun, and there's like no real hostile members or anything. So everything we do is like just pure paranoia. And we also use TLS, so if anyone's going to bother with intercepting traffic and everything and accomplish that, they might even deserve just getting access to our data. I don't know. But doesn't matter, because being paranoid is just fun. It was kind of cool to just come up with like different scenarios why something might be dangerous or might not be dangerous. So we came up with this threat model. We assume the clients or users can't be trusted because they can edit their cookies anytime, right? So we also assume TLS can't be trusted, because why not? I mean, there's been lots of research going on. There's like lots of cryptographic work going into TLS. But for now, we just assume it can't be trusted because, I don't know. And we assume apps can be compromised anytime, so like the service providers. anyone could write that app eventually, so anyone could take over that app because people make mistakes. And the more apps you have, the more risks you have, like with vulnerable code and so on, right? So we came out with some design considerations to fulfill that threat, like to protect from that threat model. One of the first design considerations was this flexibility. We wanted permissions, so we can say, okay, only users of that user group are allowed to access that app. We also wanted to be able to revoke access, because as part of a threat model, we assume apps can be compromised. So if an app gets compromised, we can just revoke access, and the app can no longer access any sensitive data. We only have a few apps planned, as I mentioned before, project management and so on. So there's no real PKI necessary. So the overhead should be manageable. So we don't really need a PKI. Users shouldn't be able to access sensitive data. So users should be only seeing some sort of token, and they shouldn't be able to do anything with that token, because we don't want users to be able to see information about how many times they might have been infracted, if there's any internal notes about them, and so on. And apps should never require users' forum data, such as passwords, which is why we started thinking about some sort of single sign-on solution in the first place. Because again, apps can be trusted, they can be compromised anytime, and so we want to give them as little access as possible. So the other solution is to use some sort of token. And the thing is about token generation, adversaries might be able to forge some MAC for arbitrary tokens. We don't know. And those tokens shouldn't really be forgeable, so we use some sort of randomly distributed byte sequence. And we store the tokens and the associated app ID. So for each app, there's going to be a token for each user. So we store those tokens, the associated app ID, and the user ID in some kind of internal database. The key management. We have some unique pre-master secret that is only known to us as the identity provider, and that is at best stored offline, or however you want to do your key handling. And then each app gets a master secret derived from the pre-master secret. You might sort of know that from like TLS. And this master secret is being distributed over a secure channel. So that could be anything, be it encrypted chat or I don't know, email, whatever you like. And we have separate secrets for the direct communication between the forum or the identity provider and the app or service provider, and the communication over the client, like the browser. And those secrets are both derived from the master secret. So in short, this is what the key derivation looks like. You get a master secret, so this is just using HMAC. And then as key, you can use the pre-master secret, and as data, you can use the app ID for like the app you've registered, and some sort of nonce, so you can do the revocation easily. So you can just delete the master secret from your database. And then the secret is being generated by using the master secret as key for HMAC again. And as data, you just use some kind of label like direct communication between service provider and identity provider, or indirect communication like via the browser. And the master secret is being stored in a database, and we just said apps are responsible for secure key storage. We don't really mind however they do that, because we can revoke access in case something gets leaked, right? So in case that wasn't clear enough, this is what a key derivation process looks like. You get your pre-master secret, which is central for the identity provider and should never get outside. Then you get the master secret, and from the master secret you can derive, with those labels, the secret key for the one communication direction and a secret key for the other communication direction. And then we thought about MAC computation. So we use that key to create a MAC to ensure that everything is cryptographically, to ensure cryptographic integrity. So we settled on a JSON Web Token format. In case you don't know that, it's essentially some sort of header, payload, and MAC. And the MAC is built using the header and the payload, and everything is encoded using base64 and separated by a dot. We are using SHA-256 for the HMAC just because we can. You might be able to use some other hash constructs, but SHA-256 seemed good enough for now. Hasn't been much in the news recently, unlike SHA-1. And then the payload and API. We get some implicit authentication through the secrets and the tokens, right? We get a token associated with the app ID, and the secret can be derived from the app's master secret. So whenever we receive some kind of request where a token is included, we can just look up what app ID is being used, and can we derive the secret from using that app ID from our master secret. And if we can build the same MAC and can verify everything seems to be fine. So that's some implicit authentication without additional overhead. And the request contains a token, and the response contains the user information at the API. The API can be fine-tuned with permissions and app-specific data. So we were able to say, we'd like to hand out this specific piece of data for this specific piece of app because it's been configured before. And so that's quite convenient, and we finally get that fine-tuning we were missing in our first iterations, because our first iterations were like just generic. So we thought about security, or rather the lack thereof. We haven't done some sort of full security proof performed yet. If anyone would like to volunteer, let me know. But I've looked into it a little bit. So it's an entity authentication protocol. So there might be some sort of matching conversation stuff going on. And our conclusion was that the key pairs for the different modes of communication should strengthen security. Although we haven't proven that yet, so if anyone has any leads, please let me know. We've identified some weaknesses. We definitely have one single point of failure, which is like the pre-master secrecy. If the pre-master secret leaks, anyone can derive the keys on their own, so we can't do anything about that. So it's really crucial to just store the pre-master secret in some very safe location. Replay attacks are possible for now. We haven't really thought about that yet, how we should tackle that. So if someone is able to intercept some sort of request with a valid token and a valid MAC from the service provider to the identity provider, they are able to just resend that request and receive the same kind of information. So we have to come up with some way to prevent that. Key revocation is easy. So that's pretty good actually, because in case something is compromised. And compromised apps can't really affect any other apps, because if you remember like that tree structure of like the key hierarchy, any app can just use any other app's keys, right? So the implementation. Stupid ideas deserve stupid implementations, so we decided to use PHP. Some outdated version even, but yeah. We used the plugin system of the forum software and hooked into the global setup complete procedure, which just gives us full control over how we want to set the cookies. And we're also building some sort of custom configuration UI, so you can create new apps and so on comfortably in a form control panel without having to use like a database in MySQL. Eventually, we were planning on having Python and Ruby support, but for now we're just focusing on PHP because the forum is written in PHP. But we think once everything is in place, it should be easy to adapt. So in this global setup complete procedure, this is the global entry point for plugins, so this is where everything gets called. Once everything is ready, the user information is loaded, everything is verified, whether the user is logged in, and so on in the forum. So this is where we can create and store tokens, can build the JSON web tokens and compute the MACs, and then store the JSON web token as cookies so it can be forwarded to the service provider eventually. And our endpoint fetches, decodes, and verifies the token, and eventually returns user data, depending on the permission level, depending on what kind of information the app needs, and so on. So there was a fun project. Some stuff we learned while doing that was that designing crypto for real-world applications is really interesting. There's like pitfalls and edge cases you wouldn't think of in a classroom setting, because in class you like see all the crypto algorithms and you think, oh yeah, right, makes sense. And then once you start like designing for the real world, you start noticing, oh yeah, there might be some sort of vulnerability in there, even though it sounds secure. So it's really easy to come up with smart sounding solutions, but it's really hard to ensure they are actually smart. And writing cryptographically sound code is really hard. We thought about some future work. We are considering implementing some kind of token binding, because it's like some sort of ongoing research issue, how you can bind the token you can use as identity to your specific browser, so someone can just steal it and like, you know, assume your identity. We're also planning on publishing the code and making it open source. This is gonna happen soon as everything is polished up, and you know, we need to make some more integrations and so on. So yeah, but it should hopefully happen sometime, yeah, this year, I hope. But yeah, last but not least, if it looks stupid but it works, it ain't stupid. It might not be like the most elegant solution, it might not be what experts would recommend, but it definitely was a fun learning exercise just for us. It was interesting to just learn about what you can do with like the infrastructure. And I mean, ultimately it works. We still get TLS as security layer over that, even though in our threat model it's not secure, but in reality it's probably a bit different. So yeah, all in all, it was just fun exercise. All right, thank you very much, and open for any questions.
Yes, there's a question.
You mentioned that there's no replay protection. Is that something you're going to be working on before you open source it, or is that not something that you need to implement for your specific use case?
We're not entirely sure yet, to be honest. So like, we're probably gonna look into it, see if we can come up with something simple. If we can do so, there's probably some way to implement it. And I mean, if you have any ideas, that's the point of open sourcing it, right?
Yeah. Also, another question. So all of this is built on top of vBulletin, correct?
Yeah.
So that's surely the weak point in the whole design.
Like I said, it's PHP.
Personal homepage is always going to be the weak point. So.
I have a question. You say if an app goes rogue, you just revoke the key. Have you thought about any automatic way to do that, or do you still need to act? So do you still need a human to revoke the key manually?
Yeah, you have to revoke it manually. That's especially why we're building a configuration UI. So you don't have to do it in like some sort of database query. But yeah, for now.
But if you have an app starting to request the 10,000 users of your database for the same app, maybe you could have some monitoring in place that just say, oh, this should be revoked, or at least temporarily.
That's a good point. I mean, it's PHP, it would probably get overloaded before that, so.
Any more questions? We got plenty of time. Use the time. Lunch won't come any earlier. Anyone? No? Okay. Well, then, thank you, Nikolai.
All right, thanks.